And yet we represent all of these in the same way, namely as files. UNIX goes beyond just manipulating files for permanent storage. UNIX uses files as an abstraction for accessing most system-level resources. So what is a file? It's fundamentally just a series of ordered contiguous bytes plus some minimal metadata to help interpret them. Yet this primitive data representation can represent so much more than just a file as we normally think of it. In this ecosystem, files are used to represent all the structures on the hard drive. Ordinary files, links, where a link is just a reference to another file, directories, where a directory is a hierarchical list of other files, but also devices such as external storage or input devices like keyboards or mice, or output devices like terminals. And also inter-process communication structures like pipes and sockets. That makes for a pretty cool abstraction because it allows us to use this as application programmers to fundamentally ignore the vast differences between these devices. But of course, in the second half of this course, we want to look below the application level. And as we do, we'll find that there are many considerations to be made down the system stack, many of which eventually turn on the idea of latency and efficiency. Reading or writing thousands of bytes may be only marginally slower than reading or writing 1 byte. So we'll see that come into play at both the library and system levels, even if we don't get quite as far down as the specific device driver interfaces at the lowest level interfacing with the hardware itself.